All right. Did you get a notification that the recording has started?
I see the blinking red circle.
Blinky. Excellent. Yes, so this presentation is being recorded for the benefit of everybody who's here, and we will be sharing it on the Meetup page. Pablo, back to you.
All right, so thanks everyone for joining us this evening, or maybe very early morning if you're joining from another part of the world, but I think most everyone here is from the Bay Area. Thanks to everyone from OWASP and also Travis who helped organize this. Today, Isaac Evans, CEO of and co-founder of R2C, will share with you a new tool and project that we've been working on called Semgrep. And if you didn't see it earlier, the slides that he will share are actually available in the chat as a PDF link. So if you want to follow along while he goes through them, you are welcome to do that. And please also use the chat to ask any questions, ask for clarification, whatever might be on your mind about what we're sharing. We're happy to do that. And Isaac will also pause periodically to look at the chat to see what questions might be coming in. So with that, Isaac, take it away.
Great, thanks so much, Pablo. So I'm Isaac. I'm here to talk to you about Semgrep. We actually had been scheduled to present this in person at OWASP SF, but unfortunately, coronavirus intervened. So we'll make do. But I'm really excited to share with you a little bit more about what we've been working on. So the too long didn't watch for this talk, just to give you right away all the information. Spoilers, is that writing secure code is hard. Even when you know a lot about security, it can be hard to write secure code. And unfortunately, static analysis security tools are often to really help developers. And although there are alternatives like grep, grep really isn't expressive enough. So what we wanted was something that is fast, code aware, flexible, powerful, and also open source. And that's exactly what Semgrep is. So we're going to be talking about it in great detail, but essentially you can use Semgrep to enforce your organization or your repository code-specific patterns and best practices. You can use it to find security bugs. You can use it to scan every PR for vulnerabilities. In fact, we're going to see just like a lot of the sort of flexibility of this as an underlying tool. One of the cool features, if you've been to the prior meetups, that we're announcing is some of the new scriptability and pluggability. So as opposed to like other static analysis tools, Semgrep is actually highly pluggable in Python. So stay tuned for that later if you've already heard some of the early material. So who am I? I'm Isaac. I'm one of the co-founders at R2C. I did my undergrad and master's at MIT and then spent some time at MIT Lincoln Labs, as well as at the Defense Department. And who is R2C? So this is a company, as mentioned, I'm one of the co-founders. We're a static analysis startup based in San Francisco, and we really care about software security, especially making that security accessible to developers. So if you've heard the shift left moniker, we're big believers in that. So the outline of this talk, we're going to have 4 basic parts. The first part, we're going to talk about just some of the background and fundamentals. Why is it so hard to write secure code? What are the things that we can do today with existing tools? And then second part, we'll introduce Semgrep. Third part, we'll go over some tutorials. So we'll teach you everything, literally everything about Semgrep in one presentation. In fact, at one point, we'll do a recap, and in 5 minutes, you will know everything there is to know about writing patterns. And then in the last bit, we'll talk about using Semgrep on your code and CI, just some convenience methods that we've created to help make it easy to get started. So first point, why is it so hard to write secure code? Here's some documentation from a web framework for Python, specifically the Flask framework. And in this framework, you can see there's a function that lets you set a cookie, and it has a bunch of default arguments. And specifically, some of these flags, which we might consider to be security sensitive, like the secure flag, the HTTP only flag, the same site flag, which can help us harden our application against things like CSRF or like people requesting the cookie over HTTP. Unfortunately, this framework is not secure by default. The defaults for all of these 3 flags are the insecure defaults. And this happens a lot, usually because the lowest friction way to get started with a tool or with a framework is not the most secure way. But as you kind of like progress in your application development, up, like, oh, well, it would actually be nice if we were using secure defaults, or if we could like enforce those defaults. This is an area where, if we look at a specific snippet, so this is everything you need in Flask to both define a route handler and then set a cookie. This looks very innocent. This is the sort of thing that you would see in like a Stack Overflow answer. But unfortunately, if we're trying to put that into a production web application, it's going to come up in a pen test, or somebody's going to figure out some sort of nasty way to hack us. Like Netflix, actually, it was just an article because they failed to set the secure flag on one of their cookies, and it got written up publicly because they had botched the response to the bug bounty submission about it. And so this can bite people in the real world, but it looks very, very innocent. So obviously, as security people, our immediate reaction is, hey, given a really trivial example like this, how can we help the developer just not do this? What kind of notifications can we give them when they're setting up this API, or to ourselves, many of us are developers, so that they are kind of instructed to do the right thing? And the easiest solution that you might think of is regexes. So, it's actually been surprising to me, having talked to a lot of security teams now. A lot of really, really good security teams have basically turned to regular expressions to automatically find things in their code base that they just know if the developer is doing something that looks like this, it's going to be a security bug, or it's highly likely to be a security bug. And grep, it's fast. It supports, in theory, an infinite number of languages. It's free and open source. So it is not at all the worst solution that you could turn to solve a problem like, hey, I want to get a notification or trigger or comment anytime somebody uses the response set cookie API with these flags. But there are some downsides. So, the problem or blessing of coding is that there are a lot of different ways to do the same thing. So there's my original snippet. Here's another example where, I import this set cookie function and then I rename it. So now I'm calling sc username Isaac E. Our grep example isn't going to catch that. If I have actually specified the secure flag equals true, well, we should update the grep expression to handle that case, because we wouldn't want to trigger there. If it's running over multiple lines, maybe because I'm using a code formatter, now we have to have our grep expression properly handle multi-lines, which is kind of a pain. If it's commented out code, that's not going to work. Or if it's something that is actually just a completely different object that we're calling this function on, grep is going to incorrectly trigger. So even in this, relatively simple example, we've seen how the fact that there are default arguments in the code, the fact that we can do import and rename, keyword arguments, which are unique to Python, multi-line code snippets, commented out code, and prefix matching are kind of barriers to this idea that we had for using grep as a really high precision, easily customizable way to give intelligence to other people in our organization about, hey, it's probably going to be a security problem if you program in this way. So to summarize, we wrote that grep expression, and we had one true positive, but then we had about 4 false positives and 1 false negative inside it. So, now we're back in the world that xkcd expresses so well. We were having problems. We had 99 problems. We used regular expressions. Now we have 100 problems. And fundamentally, what's going on here? Well, code is not a string, which is what grep and regular expressions are designed to operate on. It is, in fact, a tree. If you are using a compiler or an interpreter, the compiler, the first stage in a compiler or an interpreter is to lift the code representation into a tree-like structure. So if you haven't heard of this before, these tree-like structures are called abstract syntax trees, or ASTs. And of course, we're using the computer science definition of a tree. So it would be great if we had something that could operate on the tree. And in fact, if you look at linters and SAST tools, there are plenty of things that are operating at this level. So Node.js-scan, dlint, bandit, flake8, eslint, tslint, pylint, golint, gosec, rubocop. There are a bunch of tools that have been written. They typically operate on a AST that is unique to the language. And these are great tools. Like if you have already written a plugin for one of these tools, you know how powerful it can be to be operating on that tree-like structure. But they have a couple downsides. The first one is that every language and each one of these tools has a different way of representing ASTs. So if your team is writing in Ruby and a little bit of Go and some Python, you have to learn what the internal representation of these ASTs looks like for every language that your team uses. And then also you need a good amount of programming language expertise to cover all the idioms in this language. I can't remember how many ways there are to call a function in Ruby. There are a lot. So you need to encode that logic into your AST-based check and handle all the possible variations. And of course, commercial SAST tools not only lift into ASTs, but they also do a bunch of other data flow or other more complicated program analysis on top of it. Generally, though, they're pretty expensive, and that's the biggest barrier for a lot of teams to getting started with them. But also, even if you did sign a $1 million contract for one of these tools, you would find that in general, they're pretty hard to tune. Even for the teams that actually do development work on these tools, they're not really designed to be opened up by the end user and tweaked. So here's a quick example. This is actually a check that we wrote looking for hard-coded credentials inside Flake8. It turns out at R2C, we actually have written a lot of Flake8 plugins and ESLint plugins prior to our development of Semgrep. And this, just in case you haven't seen it before, it's not insurmountable, but it's a lot of code for something that conceptually is fairly easy to express with a pattern like grep. So really, what would our ideal grep look like? Well, we would probably want to say, we know that it's not just any response object, it's specifically the response class that comes from Flask. So if we see flask.response.setCookie, don't really care whatever's inside there, that would be the kind of invocation that we would like to have to our tool. And so in terms of complexity, if you had grep on one side and static analysis security tools on the other side, Semgrep, which we're about to introduce, would kind of sit in the middle, and it's trying to get the best of both worlds from these tools. So the good news, Semgrep is free, it's open source. You can get started with it right now. If you're on OS X, you can do a brew install. If you are on Ubuntu or some other systems, we've got installers that are, they're not in apt yet, but if you go to semgrep.dev, you can get the installers. And it actually runs in Docker as well. So if you're on some really arcane BSD system or something like that, you can still use it via Docker. We're working on getting more binaries shipped. How would Semgrep approach this problem? So in Semgrep, we would basically say semgrep-lang python -e for expression, and then sort of exactly like what we talked about earlier, flask.request.setCookie with this ... operator, and then the path to wherever our code lives. And a little bit of background, don't worry if you are sort of confused about this invocation. We're going to talk about this in great detail later on. But just to give a little bit of background, so this is free and open source. It actually didn't originate at R2C. It was originally a Facebook project. And Facebook uses this heavily internally to enforce rules on their code base. So the original contributor actually came from a place called Enria, where he did his PhD. If you know Enria, you may know a project named Coccinelle, which was one of the first semantic patching libraries for the Linux kernel and has made a bunch of forward patches to it. So we've got a kind of rich history of program analysis legacy behind the tooling that we're about to show. So as mentioned, semgrep.dev is on GitHub. You can go there and start it. The .dev domain is just a redirect to the GitHub page. All right, so let's see what Semgrep can actually do. And for these tutorials, we're actually going to use, we're not going to use Semgrep on the command line, although you're welcome to follow along there. We have a really nifty live editor that we're going to use. It's at semgrep.live. It's linked from the repository to run through these tutorials. So the first one, let's imagine that we're a Node.js shop. We know that there are some scary APIs in Node. In particular, there's an API named Exec. And we would just really like to know, or maybe prevent, developers on our team from committing code that uses Exec. So this is a really simple example, but I'm going to pop out here and zoom in. Pablo, is that still working okay? Just to double check. Pablo may be muted. I'm going to assume that it's going okay unless somebody in the chat tells me otherwise. So what we've got here is we've got the Semgrep pattern up here. This is our -e. And then we've got a little code snippet. And then we've got, the matches will show up over here on the right. So this is actually structured to look exactly like that example that we had with grep before. We've got some commented out code. We've got stuff that looks like code, but it's actually in a string. And we've got some like weird multi-line stuff like that. So in Semgrep, we basically just copy and paste the code snippet that we care about from the code into our query. And then if I run this, you'll see that basically it just triggers on this one here. So it's found this one, it hasn't found that one. But I'd really like to find it with anything inside it. I don't care what the name of this foo bar or whatever, even if it's invoking a function inside it, I would like to trigger on that. So for that, there are two fundamental operators in Semgrep. The first one is this ... operator. So if I put ... here, no matter what's inside, this is going to match. So in fact, this correctly finds these 4 cases that we wanted to find, and it ignores the cases that we would rather not trigger on. So this is great. Like depending on how much regexing for code you've written, you may appreciate like how obnoxious it would be to handle this like nested parentheses case. Even if we have like multiple arguments to exec, the ... operator will take 0 or more arguments. So we'll come back to that in a minute, but this is just sort of a basic example. We've got the pattern, we've got the code, we've got the matches over here on the left. So that was node exec. Let's see something a little bit more interesting. Here's an example for Golang. So we might want to find, our Golang server is starting, but it's not serving the website over TLS. So we've got some examples of this. There's a specific function named listen and serve TLS, which we would want the developer to use, but they're not. So again, I can just copy and paste this code here, paste it into the pattern. This is a different language. You can see we've got Go selected, but again, I'll just replace this with the ... operator. And boom, we successfully trigger, just to show you that this is white space independent. I can put some indentation, no problem. Great. So let's go back and look at a really basic example, but something that starts to get at the other operator. So I promised that there were 2 operators in Semgrep. One of them is the ... operator. The other one is what we call the metavariable operator. So this lets us say, like imagine we want to match some variable named foo. We really don't care, like if it's named foo bar instead, but we want to be able to refer to it later on. I see there's a question in the chat about how can you get the recorded video. The recorded video is going to be posted to the meetup page we are recording now after it's done. So 4 a.m. sounds very early. I hope you get some sleep. Coming back to the example, so this $X lets us basically say, you know what, I don't care about what that variable is called. And if I use it again, it'll enforce equality constraints on the variables. So in this example, we've got like foobar equals foobar. If we run that, it's going to trigger. If we put foobar2, it's not going to trigger. And this is sort of exactly what we want, right? We want to be able to like use placeholders, but named placeholders, these metavariables, to refer to things in the code. So these have been fairly basic examples. Now let's do something really complicated. So here we've got, like something that is a classic injection attack. We're sending a file which is actually controlled by the URL back to the user. So get file, in case you're not familiar with Flask, this file name argument is going to come from the route, which means that it's controlled by the user, and then we're going to send whatever file name they specify right back to them, which is obviously bad because now they're just pulling arbitrary things from our server. So for this, we're going to rely on all of the concepts that we just used. I'm going to copy and paste this whole function in here, and then I'm basically just going to start emptying out stuff that I don't care about. So I'm going to put a ... because I don't care about what's in the body of this function. And this is the first time that we've used the ... operator, not for just arguments, but you kind of get a sense for, oh, this works for statements as well. And then we don't want any function named send file. We want the Flask send file. So I'm going to say return flask.send file in my query. And I'm just going to say, like for the purposes of our initial demo here, we don't care what the arguments are to the function, and we don't care what the arguments are in this return invocation. We just want it to match. So boom, looks like it matches. That looks great. But now the question is, well, if you're sending something different here, like file name 2, it would be great if that didn't match, right? Like the whole point of this check is that we want to find somebody who's sending file name and using that same file name inside the send file function. So as you probably guessed, we can use these metavariables to go back and enforce that. So if I put file name here, and then I put file name here, to just match one argument. So I'm going to put the dot, dot, dot so that I don't care about the rest of the arguments. And now this doesn't match because I've got file name and file name too. But if I change this so that it is the same, boom, we get a match. So there's a question in the chat about, is it possible to use Semgrep to detect user-controlled parameters that travel through multiple source files before being used in a SQL query? We will come back to this later. There are some trade-offs that Semgrep makes versus a traditional static analysis tool, which make the answer to the question, it depends, basically. But this is a very basic example, right? Like we're just inside the same function using the same thing. So we haven't demonstrated anything that's crazy complicated yet. That will come. Cool, so we saw a basic example of what it would look like, to like match something where we've got an injection traveling from the arguments to the function all the way to this return parameter. Let's go back to the cookie problem that we had at the very, very start, our first motivating example. So we've got this response.setCookie. And for this, we're actually going to introduce a more complicated syntax because we don't want to just match this thing. We want to match and display a helpful message to the developer or the other people on our team who are looking at this. So for this, Semgrep supports a different syntax. This config file is in YAML syntax, and you can run this locally. So one thing I haven't shared is that for all these things, I'm just pressing Command Enter to run it. But if I say run locally, and you've got your Semgrep install through brew or apps or whatever, you can say semgrep --config, and this can be a local file, it can be a URL, or you can do it with Docker, which is super neat. And in this case, it's actually generated a unique share URL for the snippet pattern that we've got here, which is pretty nifty. So coming back to this YAML syntax, the first thing we want to do is give ourselves a rule ID. So we'll call this like secure set cookie, and we'll tell the developer like, please set the secure equals true and HTTP only equals true flags. It's a little bit confusing in case you haven't seen this part of the spec before. HTTP only means that it will actually go over HTTPS if secure equals true is set, but it can't be used in JavaScript, like XML HTTP requests are set. See our security policy at xyz.com/secpolicy, whatever. And now, so previously we've been working with these single patterns. Let's see what that looks like. So we've got flask.response.setCookie. Yep, we're triggering on all three cases inside this code snippet. That's great. But we want to combine these. We don't want to trigger on the cases where people are actually setting the secure equals true flag and the HTTP only equals true flag. So if I come back here, I'm going to start by saying, okay, pattern looks like this. So flask.response.setCookie. But then I want to filter out the cases where people are doing the thing that is actually okay. So let's snip this real quick. We'll just run one pattern at a time. So just like in the single pattern example, we're now having the YAML do the exact same thing, but we've got our message coming through, and you can see the ID reflecting there as well, which is nice. So if I undo that, now I'm going to say, okay, pattern not flask.response.setCookie. And as you can kind of guess, hopefully by this point, I'm just going to copy and paste these flags right into the code. I don't care about what happens before or after them. I'll resize this a little bit to make that bigger. Great. So if you're grokking the Boolean composition here, I'm basically saying, hey, if the pattern is not this, but the pattern looks like that, then let's trigger and display a message to the user. So I'm going to run this, and now this is looking great. So we've got this here, this cookie is secure. This one is not being triggered on. This one here is being triggered on because we've got secure equals false. Even if we made this secure equals true, it's still going to be displaying this message to the user because we were looking for both of these flags being set. So hopefully that's pretty straightforward. There's a lot more to the YAML syntax and a lot more operators that you can put in here that we'll talk about later. The last thing I'm going to show you, though, is really cool. So what if, actually somebody just asked this in the chat, what if secure and HTTP only are flipped? This is a great question. So let's take secure and let's put it after that and see what happens. Boom. So just as we'd expect, we're not notifying the user that this cookie's bad. We're still just looking at those two. And in fact, this is one of the things that's really cool about Semgrep. So, there are some other systems that will extract to a generic AST, but they lose some of the language specific properties. So because Semgrep knows that this is Python, it has what we call an equivalence for Python. It knows that in Python, keyword arguments, the order of the keyword arguments doesn't matter. So it will, actually maintain that property even after it's like raised this into a generic pattern matcher, specifically because we're in Python code. If this was in another language, that wouldn't necessarily happen unless the language supports that semantic. So again, this goes back to one of the obnoxious things about writing your own linter rules. You have to really become an expert in all of the different variations and ways to do things in a language. With Semgrep, we've encoded a lot of that into the tool, so the tool just kind of automatically does the right thing for you in these cases. One of the things that is not released yet, but is under development, is the ability to actually add your own equivalences, so that if oh, hey, this language has this pattern or this other way of doing it that's actually the same as what I'm trying to do, you can actually do that on a per rule basis. So let's imagine you wrote a rule that's like, well, in this rule, it doesn't matter if it's x plus y or y plus x, even though for some other rules that might matter. Being able to just embed that into your logic is one of the things that's coming up. Cool, so good news, we solved the cookie problem. That's great. Here's the full solution to this. So it looks really, really similar. We've got a much more descriptive message that's being displayed to the user is the only difference. So now let's do something that is a lot more custom. So here we're going to switch to Java as an example. We're imagining that we've got something that is not a universal, this would never be part of a static analysis tool that you would buy, but it might be really specific to your application. So let's imagine that we've got two functions, verify transaction and make transaction. And in our business logic, you always have to call verify transaction before you call make transaction. So here we've got some Java stuff. There's a little bit more code here, so I'm going to try to drag this and expand it. Again, you can see that we've got a couple patterns. I'm composing a pattern and a pattern not. One of the cool things that I haven't mentioned is that you can actually use these metavariables inside the message. So you can see here it says in $method, and as long as there was a method that could be matched inside the pattern, it's automatically filling out the names of the methods inside the message to the user, which is great because rather than it being super generic, you can actually be like, hey, in this thing, it's this variable in this function named such and such. That is a problem. So all right, we're looking for in $method, there's a call to make transaction without calling verify transaction first. Let's take a look at how we're doing. This case is okay because we called verify transaction before make transaction. This case is bad and we're triggering on it, so that's right. This case is bad because we called make transaction. We verified it after we made the transaction. So that's not what we wanted. And actually, if you look at what these rules are doing, again, we're using the ... operator to come through and say, hey, I don't care about what's in between these calls to these methods at all. Here, we've got verify transaction with no call to make transaction. So that's fine. They're just verifying it. And then here's something that's a little more subtle. I'm going to show you some other examples. Well, there's some other examples here just to show you that the stuff that's in between doesn't matter. But here's one that's really interesting. So here we created a transaction named other, we verified other, and then we didn't make the transaction with other. But we're not flagging on this as something that's wrong. So again, it's kind of easy to imagine how this is going to work. To fix this, we're just going to go back to this pattern not. And we're going to use a meta variable for the transaction that's in the middle. And we'll use the same meta variable, which should mean that it's referring to the same object between these two calls. So when we run that, boom, indeed, we do hit at line 53. We've completed the pattern, and now we've got this sort of custom logic working in the way that we'd like. All right, so there is one more tutorial, and this one is actually something I'm really excited about because we just added support for it to the tool. So it turns out if you're writing Python, there's a built-in Python function named exit, And then there's also sys.exit. So if you import sys.exit, that's actually a different function from exit. I did not know this, as it turns out. And we ran into a bug in one of our applications because this like exit function, just the built-in exit, is something that is a Python built-in. It's built into the CPython interpreter, whereas sys.exit is available on like every standard Python implementation. So because one of our projects was running on a non-standard, like not CPython, we ran into this weird bug and we were like, what in the world? Why are our exit calls failing? That just doesn't make any sense. So I've got, like using the same stuff that we saw before, I've got a pattern. It's fairly obvious. It's like exit $X, and I've got a message that's saying, hey, use sys.exit over the built-in Python exit built-in, blah, blah, blah. And I have a link out to the Python, or well, a Stack Overflow answer in this case. What's really cool is that there's actually support for another operator called fix. So if I type fix, I can give the developer a suggestion for what should go inside, like what should be suggested as an auto fix for this basically. And the live editor, like you can run this locally with the autofix flag and it'll stage the changes. And the live editor has a nice little thing that will show us, hey, this is the autofix suggestion. I can just click apply fix, and then boom, I've actually like just live patched the code to do exactly what I wanted. So this is one of the strengths of using, the concrete code syntax. We're using the same syntax for the query. It looks super close to what is in the code. That makes it really easy for a lot of the things that we've done to either specify an exact fix as works in this case, or to just, like sometimes there's not like, you can't give the developer an exact, like, hey, this is what it should look like, but you can give them an idea, right? You can be like, yeah, it should probably look something like this. And that's always great because, like the #1 complaint that people have with these tools is that they create more work. So if you can be in the category of tools that are creating less work rather than more work, that's awesome. Cool, so that was a lot of tutorials. I think there were 6 in total. We're gonna do a quick recap. So if you got kind of lost in everything, this is the learn Semgrep in 5 minutes that I promised. We may actually go faster than 5 minutes. The first concept is code equivalences. So this is what makes it a semantic grep. So the fact that in Python, you've got like, keyword 1, keyword 2, and will still match keyword 2, keyword 1 is a semantic equivalence. The fact that subprocess.open will match, from subprocess import open as something else, this import aliasing. If we do import foo.bar, that will match from foo import bar. These are all things where Semgrep knows about the semantics of the language. So one pattern can match variations of equivalent code. Just to show you an even neater example of that, here's an example where we've got like some dangerous function that we're trying to find whenever anybody calls it with a literal string password. And even though like password is not called in here directly, Semgrep actually does what's called constant propagation on the source code. And so it will like actually understands that even though we haven't literally specified password here, there's a constant which refers to that that is actually going in. So this actually, like if you were writing in a standard linting tool like ESLint or Flake8, they don't actually have the level of program analysis power to be able to do things like this. So this is one of the things that actually makes Semgrep more of an easy to use SAST tool rather than just an AST-based linter. So that was the first concept, equivalences. The great thing about equivalences is they just work. You don't have to know anything about them in order to take advantage of them. So that's really cool. The ... or ellipsis operator, we talked about that already a little bit, but just to make it super clear, so that will match arguments. So here it'll match anything that has 5 as the last argument in a call. You can actually use it to match strings as well. So string is just a sequence of characters. So if you put that in here, it'll match any kind of hard-coded string. You can imagine using this for like hard-coded secrets detection and things like that. And then you can also use it to match lists of statements. So it'll skip over these 2 statements in the middle right there. So only 3 concepts in Semgrep. #1 was equivalences. #2 is the ellipsis. #3 is metavariables. You've seen a little bit of this, but you can use metavariables all over the place. They just have to start with a $sign and then contain uppercase ASCII characters. They can match expressions, they can match statements, they can match names, they can match decorators on functions. And then the really fun thing is kind of, when you use those equality constraints, I showed you the x == x example. there are other fun things you can do, like this one has found a lot of bugs for us. If expression, $S, else $S. And this will actually greedily match a whole list of statements. So if we've got foobar and foobar on both sides of the if else, this will match. And of course, that's because Semgrep is enforcing an equality constraint across those metavariables. Great. So you may be wondering, hey, what languages does it support? What languages are coming? Python, JavaScript, including JSX, Go, Java, and C are currently supported. TypeScript and PHP are in development, and actually Ruby is also in development. I should update the slides for that. And then Semgrep is licensed under GLPL, so we would love your contributions. It's like very, very friendly to get started with. So I'm going to pause real quick and just check for questions in the chat before I get into some of the registry stuff. So one question was, can we use this tool in mobile applications that include remote JavaScript files? You would need to fetch, the Semgrep won't fetch the remote JavaScript file for you, but if you bring those JavaScript files down locally, you can analyze them no problem. I mean, it's a Unix tool, so you could technically set up some sort of piping workflow to make that happen. The next question is, well, this was sent to me privately, but it looks like a question for the group. With constant propagation, does that always halt, or is it possible for a really slow code file to break Semgrep? The constant propagation will always halt, but it definitely slows it down a little bit, to do the constant propagation. Still, you're talking like 10,000 lines of code per second, so a lot faster than some of the other tools out there that, like especially static analysis tools can take like hours to run. I'll cover that a little bit more when I talk about some of the trade-offs. And then there's a question about functionality rise. Could you compare Semgrep to GitHub's CodeQL? Yeah, so CodeQL is an awesome tool. It's actually been around for a good while. Some of our seed investors and advisors worked at a company called Fortify that, as I understand it, the folks behind CodeQL used to do some work with. So if you haven't seen it, CodeQL is made by a team out at Oxford, and they were recently acquired by GitHub. I would say that, in terms of philosophy and focus, Semgrep is more optimized for the security engineer, and CodeQL is more optimized for the security researcher. So CodeQL, also allows you to tailor and customize things a lot. It just tends to be, like a little bit more complicated to pick up and learn for the first time. So if you are doing a project where you are going to spend, months investing and learning exactly how to find a specific kind of vulnerability, that makes a ton of sense. If you're a security engineer and you just want to get started because you know exactly that you have this like make super user function that nobody in your code base should be calling, Semgrep makes a little more sense. And some of the decisions that are made in terms of performance, Semgrep optimizes for speed, whereas I think CodeQL optimizes for like deep data flow. Are you planning to release a Git repo with scanning rules for common security issues? Well, this is exactly what we're about to talk about next with the registry. So let's get into that. There is, in fact, a community rules registry. So if you've installed Semgrep, one of the features is that, we talked about this config option can be a remote URL. It can also point to a folder full of YAML files. Those YAML files are going to look exactly like what we just saw in the live editor. And if you go to semgrep.live/registry, that will actually redirect you to a GitHub repository, which is just full of a bunch of rules. The intent of the rules is not to be like a perfect replacement static analysis tool. It's more of a collection of, hey, these are things that people in the community wrote and found useful. So we don't do any gatekeeping on these rules, but there's tons of examples of things that other people have found that you can kind of mix and match. In terms of community participation, so we have on the order of hundreds of rules right now, some developed by us, some developed by the community. If you're familiar with Node.js Scan, which is one of the best open source Node.js scanners, it's actually like if you buy GitLab Ultimate Edition, this is the tool that's included for scanning JavaScript. The latest version of Node.js Scan is actually powered by Semgrep. So we know the author, he's a fantastic fellow, and he's ported his entire tool to use Semgrep as the engine, which is awesome. We've also worked a lot on just getting rule ideas suggested by people who are expert programmers in the community. So the co-creator of Django has contributed a bunch of rule ideas. We've solicited input from the Flask team for Python. And then we've got a whole collection of independent security researchers, some of whom are probably in the audience, who have found us via HackerOne or other ways, who are quite good, who are writing a bunch of rules as well. So, obviously, if you are just running, like if you're looking for kind of like, hey, how could I just replace my SAST tool with this? You probably do care a lot about the false positives. We'll talk a little bit about, I think it's important anytime you're consuming free open source tools to understand the business model of the people who are contributing to them. One of the things that R2C is working on is a curated version of the registry, so that if you don't want to set everything up yourself and you just want a hosted system that works well with low false positives, we do a bunch of vetting behind the scenes and tuning on the rules to try to make them better. So here's what the community rule registry looks like. semgrep.live/registry will take you there. Rules can be tagged with like security, CWE, OWASP tags. Currently, we have coverage for the OWASP top 10, actually across most languages, which is pretty neat. A month ago, almost none of this was there. So it's been growing really fast. It's a new tool. We would love more contributors. And let's talk a little bit about what it takes to tune the rules. So, coming back to this like x == x example, here's like a really basic YAML file that we've created. We've got this like stupid equals check, x == x. But if we run this on a bunch of code, so R2C internally, we have this MapReduce platform that lets us take a rule and run it over like giant swaths of the ecosystem, like everything on NPM or most of the things on GitHub. We'll quickly discover that there are a bunch of snippets like this one in the bottom right, where it's like assert 1 == 1. And if we went and showed that to a developer, it's like, well, okay, yes, I get that that's always true, but like this is test code, dude. Why are you bothering me? So we can combine it, like with something like this to say, and I'm showing you this example because this is actually exactly how we tuned the equals check that is in the community registry. So, the first thing we do is we come through and we're like, hey, if this is inside an assert, we assume that the developer probably knows what they're doing. That might not be true in the general case, so there's going to be some false negatives. But because we really care about not annoying the developer who's looking at these, we're going to do it. And after a few more rounds of iterations, looking through the results in thousands of repos, we ended up with a config that looks like this. So we're basically saying, hey, if we're inside all these kinds of asserts, if we're doing 1 = 1, if we're inside an EQ function, we don't care about this. And then we added a really nice helpful message to the developer that's basically just saying, hey, the only time you would actually want to do this is if you're checking for a floating point, not a number. There's actually some better alternatives that you could use, like math.isnan, to check for that. Once we had it tuned like this, suddenly we got very, very few real hits. And the hits that we did get were in some really cool projects. So this found bugs in Scapy, libcloud, and the Azure Python SDK, which is pretty cool. So that's like part of the work that we're doing behind the scenes is basically trying to use the tuning of this MapReduce platform to make it easy, or like to increase the precision of the rules that are in that registry. So just to show you more of what it looks like to iterate on the rule languages. So like on the web UI, Semgrep Live, we just had that radio button that we could push to change languages. But in the YAML syntax, you'd want to specify the actual language. And then here's something that is really interesting. So I teased this at the start of the presentation, and it's the first time that we're talking about it publicly, but we've added support for a pattern where Python. So sometimes, you might be like, oh man, what I really want to do is I kind of want to just extract a string from the code base. And then I've already got a Python function that I can run it through that will, look for like, hey, is this like a base64 encoded thing? Does it look like an AWS key? Stuff like that. So with pattern where Python, you can actually refer to the metavariables and you can just run arbitrary Python code here, which is awesome. So like any kind of like custom work that you'd like to do, you can just drop in. Because we are a security startup and we're security conscious, this requires a flag that is not enabled by default. So you're going to have to run with this really long flag, basically saying, yes, I know now that my rules could run arbitrary code. If you're running something from somebody else, it could be malicious, of course, but it's a really powerful tool to be able to have. And in fact, there are a bunch of operators that we just don't have time to talk about. So here's a snippet from the documentation. You can actually use regular regexes. So you can kind of combine grep and semgrep to get the best of both worlds. And one of the things that is also super recent is semgrep is now available as a Python library. So you can just pip install it. You can use it as a dependency in your other projects. And just to give you a little sense of what's going on inside the code base, the core program analysis work is actually all done in OCaml. If you've ever looked at anything coming out of Facebook that is program analysis related, it's all OCaml. That's because Johan, who was the first program analysis person there, is a big OCaml fan and started that whole effort. But there's actually a layer on top of it. So like all the stuff that you've been seeing with the YAML files, like the Boolean composition and things like that, are implemented in Python. So if you know Python, there's actually a ton that you can do to both improve the tool or like make it more scriptable, pluggable for your environment. It's really easy to get started with. So in terms of integrations, like one of the things that obviously you'd want to do this for is finding bugs in code, bonus points for CVEs. Looks like my animations got a little screwed up here, so you're getting a sneak preview. You might want to enforce secure defaults. So if there's like, hey, at our company, there's a way that people ought to open files, and like it's this secure open function that we've created. Or secure frameworks, like, hey, we know that anybody who's writing this app ought to be importing our special logging library, which just handles a lot of issues. It's easy to do that. We've tried to make it really easy to just get started with adding this to CI. There's a Docker container, as mentioned, that you can use, or a JSON or Linux binary. There's a --JSON flag, so you can just get JSON right out of it. And here's an example Circle CI config. We have a GitHub action, which you can see in the bottom right. Unfortunately, GitHub Actions add a little bit of overhead. They add like 20 seconds of overhead. But even on this 20,000 line commit, if you expand this, the actual Semgrep runtime is about 3 seconds, which is pretty nifty. And there are a bunch of other cool features that are coming soon to Semgrep. So one of the things that I mentioned is more code equivalences. So like we've done a lot of work for adding support for the languages we support to be able to say, hey, like this and this are actually the same thing. So let's just collapse them so that somebody can write a pattern that looks this way and it matches all those other variations. We want to make it easier for other people than just people who know OCaml to contribute those. So that's on its way. Another thing which you can sort of imagine being pretty straightforward in terms of the syntax is to integrate typing information. So most of the languages that we're talking about, Python and JavaScript, have both added extensions that support types in those languages. So TypeScript for JavaScript, and then of course Python just has typing as of a few minor versions ago as a built-in part. So it would be really nice if in our query we could say, oh, like, hey, this metavariable, I want to capture it, but only if it matches this type inside the program. And then also, as mentioned, Ruby and TypeScript are on the way, along with PHP. Turns out PHP is actually like almost supported 100% already because that's what Facebook used. So we would love feedback about, hey, what are the next languages we should support? It's actually quite easy for us to add support for a new language. We're working on making it even faster. So even if you have something exotic like Lua, send us a note. Be like, hey, I would really enjoy having this supported. So the final part of the presentation is, hey, help us make Semgrep better. So we have a bunch of rules for specific frameworks like OWASP 10 issues in the registry. You can find all of these on your own, but if you take our survey after the talk, we will email you a nice curated selection that you can test out. So we would really appreciate feedback on the survey, feedback to help me become a better presenter. And then we are working, our startup is building a next generation hosted static analysis security tooling product with Semgrep as the core. So, if you have some SAST tooling that you use right now, but you're not in love with it, we would love to hear about, hey, what do you like? What do you dislike? How can, we make Semgrep better to make it useful for that? And of course, for people who just want to use the open source parts and everything that we've showed is open source, we want to support that as well. So we've tried to make it super easy to share rules and contribute security expertise. So if you're on the semgrep.live editor, you can actually create a short link for your snippet. And if you feel like your snippet is pretty decent, you can just publish it to the registry and it'll just create a pull request right there. So don't be shy about that. It's easy to do. And yeah, that is basically it. So this has been Semgrep. Just as a summary, in case somehow you're tuning in at the very end, it's an open source code analysis tool that's designed to field like grep, make it easy to match code patterns, super fast, supports Python, JavaScript, Golang, Java, and C. And you can either play around with it in your browser on Semgrep Live, or install binaries, or use it via Docker. So yeah, with that, I will let people unmute themselves if they like, and feel free to ask questions in the chat. But thanks so much for being a great audience. Like, the questions that we already had were awesome. I really wish we could have had this conversation and meeting in person. So I'm looking forward to the next time the OWASP SF meetings happen in person. I hope to meet some of you there. Cool beans. Well, it looks like most folks got their questions out already, so I think we are done. Last thing I'll say is we're a tiny startup. We have a small team. Feedback is super helpful to us. So if you think this is something useful that you're going to be using, there's a Slack that you can find on our repo. We'd love to meet you, learn more about you, and contribute together towards a really cool open source tool. Thanks so much, everybody. Pablo, I'm going to stop the recording.